Good morning, everybody. So this is our 750 economic growth. Today, we're going to look at some endogenous growth models. Okay, so let me show you first some classification of endogenous growth models. One type of models build on Marshallian externalities. Okay, and another type build on Schumpeterian innovation. Okay. Now, in Marshallian externalities, we have some early work by Kenneth Arrow for physical capital accumulation. Okay, and some early work again by Uzawa on human capital accumulation. All right. So these are 60s. These are the models that developed at 60s, in 60s. Then Arrow's model has been extended by a nice paper by Romer at 1968. Then the Uzawa paper has been extended and generalized by Robert Lucas in 1988. Okay, so these models deliver endogenous growth through the Marshallian externalities. In the literature, sometimes they are called Marshall, Arrow, Romer externalities. Okay, so that's also an abbreviation that is used. On Schumpeterian innovation, we have a couple of different models. There are first generation models, Romer 1990, Grossman and Helpman 1991, Agion and Howitt 1992. So these models are subject to scale effects problems. So we're going to see that in the next weeks. So the scale effects problem is there for the first generation models. So Jones actually showed that. Then there would be semi-endogenous growth models. Okay, semi-endogenous. Semi-endogenous models, so these are Jones model and Kortum model, for instance. Okay, 1997, I guess, Kortum. So there's first generation models, the scale effects problem, semi-endogenous models, and then we have second generation Schumpeterian models. Pareto, Young, and some other guys, okay, after 1998, okay? So we're gonna cover such models as well. Then, of course, at some point, we're gonna start looking at unified growth theory. Okay, so that's also endogenous growth. But today, our purpose is to understand this Marshallian externality models. Okay. So let's start with something very simple. Okay. So let's suppose that let me change color here. So here, this is from Agion and Howitt's textbook. Okay. I don't remember which chapter was that. Agion Howitt's textbook of 2009. Okay. Chapter 2, perhaps, if I remember correctly. So now we are imagining an economy that has many firms. Okay, so suppose that these are the firms that produce a single good. All right, so the good is the same, and each firm works with this technology. Okay, so there is there's a productivity level. Okay, A is productivity, and that could be common across firms. And then there is the capital stock, okay, per each firm. And there is also, so here we also have a typical exponent, all right? So for now, we assume that labor is fixed, okay? So labor could be a constant. To understand the, the heart of the problem, we don't need labor in the traditional sense. Now the idea is this: this productivity term, so A is productivity, right? Now productivity will be an endogenous variable, okay? And productivity will be depending on total capital stock in the economy. Okay, so here eta is some curvature parameter, and C is some level parameter. Okay, so what do we see here is that, all right, the main idea is this: if the economy gets more mechanized, okay, if there are more machines around, if there are more equipment around, then each and every firm becomes more productive, right? Because if you assume A is equal to 1, a constant, or if you assume, for instance, eta equals 0, right? This parameter eta that governs the productivity effect of machine stock. If it is 0, for instance, then you will have a constant A. Okay, so you would go back to the solo version, right? But here, there is such an externality. Okay, there is such an externality. So we want to understand that. Okay, but if this is true, now think of what happens. The aggregate production will be equal to what? It will be equal to this, okay, and the aggregate capital will be equal to this, all right? Now, with heterogeneity, it is of course difficult to understand equilibrium, right? I mean, so there could be, so if you think of this simple setup, and if markets are, competitive, and no firm has any power, etc., you would imagine, just looking at this production function, that equilibrium will be symmetric, right? So if there's an allocation problem somewhere, if we really solve this model, since production technology is the same, firms will arrive at the same solution. Okay. So then what happens? Well, if total capital stock is the summation of all this, right? And if they're identical, what do we have? Well, we have total capital stock being equal to N times K, right? So K here now is, of course, the firm level capital stock, and big K is aggregate capital stock. Okay, now if this is true, the production of each firm, production level is also the same, right? And we can write this as what? We can write this now as C N times K to the eta, right? N times K to the eta. Then I have K to the alpha. Okay, so put differently, you can write this as C N to the eta and K to the alpha plus eta. Okay, so let me use a different color. So now you have, in equilibrium, a firm level production level that satisfies this equation. Okay, so what do I see here? Well, originally I have decreasing returns to scale, right? So the firm actually has decreasing returns to scale because alpha is between 0 and 1, right? But because productivity is endogenous, right? Because productivity is endogenous and it is endogenous to the changes in the aggregate capital stock, because of this positive externality, here, of course, we have this positive externality. There could be, depending on the size of this externality, right, eta, we could have decreasing returns to scale, constant returns to scale, and increasing returns to scale. Okay, so when we put the positive externality in this particular way, then we have three options. The model is now much more general in that particular sense, right? And now we can also do this. So we have the firm level production, right? So it is C n to the eta k to the alpha eta. So this is again a symmetric equilibrium. Okay, so symmetric in the sense that this is true, right, for all firms in the economy. Now the aggregate GDP is what? It is also this, right? So I have that, and then I have that, so it is equal to this. So if I write that, we have n times c and eta k to the alpha eta, right? Now you can actually imagine this. So k, if you think about it, k is this, right? So now you can write this then as n c n to the eta k divided by n alpha plus eta, right? So aggregate GDP is what? You have n c k to the alpha eta, right? Oh no, you also have so this is 1 minus alpha. Okay, so either at the firm level or at the aggregate level, there are three possibilities: alpha plus eta less than 1, alpha plus eta exactly equal to 1, okay, and alpha plus eta greater than 1. Now, where to proceed from that point? Well, let's go very simple. Okay, let's do this. To understand growth in this economy, obviously we want to understand how k changes, right? Now, the simple possible way is this, right? The simplest possible way to understand how aggregate capital stock changes would be through constant savings, right? It would be through constant savings. So we have sy minus delta k. All right, so we have k dot equals s times, so s here is the saving rate, delta is the depreciation rate, So S times Y. What is Y? Y is N1 minus alpha C K to the alpha eta minus delta K. And the growth rate of K is simply S n to the 1 minus alpha C K to the alpha plus eta minus 1 minus delta. Okay? Now, this is a differential equation, obviously. And there are three possibilities again, right? So let's draw these possibilities. Okay, suppose that this is K and this is G of KT, right? So this is K dot divided by K. So if this is 0 and this is minus delta, now one possibility is that we have decreasing returns to scale, right? So alpha plus eta is less than 1. So there is no growth in the steady state. There is a steady state, all right? Or we would have a positively sloped. Remember the equation. The equation is K dot divided by K is S n to the 1 minus alpha C K to the alpha plus eta minus 1 minus delta, right? So if alpha plus eta is greater than 1, so you would have, for instance, something like that, okay, in general, right? So this is alpha plus eta greater than 1, so it is positively sloped. Or alpha plus eta would be exactly equal to 1, and then, for instance, you would have something like this. Okay. Now, in the red case, the equilibrium is of course stable. We know that from Solow model, right? In the case of blue equilibrium, the equilibrium is unstable, right? Because it is positively sloped. And in the green case, so depending on this level, so in the green case, I have what? I have GK is always constant, right? And is equal to S n 1 minus alpha C minus delta, right? So if S n minus PC is greater than delta, then G of K is positive, right? So that would be G of, let's denote it by G of K bar, okay? And of course, it requires either S is large enough or N is large enough, right? Or C is large enough, right? So that particular condition requires that. But eventually what we see is that, okay, so there is this constant growth rate and the economy enjoys constant growth. Why do we like that? Because we already assume that in the green case, we already assume that labor is fixed, right? So GDP per capita, so if labor is fixed, GDP per capita is basically aggregate GDP, right? Then the growth in aggregate GDP explains growth in capital stock. Okay. Now, in the blue case, when there is increasing returns at the firm level and at the aggregate level, of course there is this unstable equilibrium. Such unstable equilibria is not very easily handled, right? Using the typical. Let me shut this down. So in this particular version, if we want to get close to the empirical facts, we require alpha plus eta to be exactly equal to 1. And this is not very good from a methodological perspective, because this is a singularity assumption. What do I mean by singularity assumption? Well, alpha or eta must be equal to exactly 1 minus alpha. Okay, but these two parameters are totally different things, are about totally different mechanisms, right? Alpha is about how capital stock is important for output. Eta is about how capital stock is important for knowledge. Okay, so these two are entirely different mechanisms. Okay, so we don't like singularity assumptions in graph theory a lot, because this can be true only by chance. Okay, and we don't want to do that. But the good news is that Romer, in his 1986 paper, so this paper is from his PhD thesis and published in Journal of Political Economy, he kind of resolved the problem. Okay, so within a general equilibrium model, Romer offered a different conceptualization of knowledge and increasing returns. Okay, so we understand how we can actually study economies that exhibit growth with increasing returns. Okay, I'm not going to go into details of the Romer version. I'm just going to show you a simple planar version. Okay, but let me remind you of one thing. Now, remember the first fundamental theorem of welfare economics. It says, under certain conditions, a Walrasian equilibrium is Pareto efficient, right? So this requires, so what are these certain conditions? Well, we have a couple, but one thing we require is there's no public good. Another is there's no externalities. Okay. Another thing is that there is no asymmetric information. And another is that there is no missing markets. Okay. Now, obviously here, we have an externality, right? So the competitive equilibrium, when I say Walrasian, what I mean is competitive equilibrium or decentralized. Okay, so that obviously may not be Pareto efficient. Okay, because of the externality, and we actually understand that. You know, we see the problem here. So why I for firm is defined in this way. Okay, so what does this firm do? Well, this firm writes the profit in this way, right? So it's if we normalize price to unity, so there is a particular rental rate, okay, and the firm solves this problem, right? Now, the important thing is this: when firm solves this problem, okay, the firm takes A as given. Why? Well, no firm will think they can affect the market outcomes. Okay, so there is a large number of firms, and each firm's share in the market is small enough. So when I take a decision, even if I know that a more mechanized economy would be more productive, I do not take into account the effect of my decision on A. Okay? In other words, I do not internalize the externality, right? But the situation would be different for a planner. Okay? So decentralized versus central planner solution. Okay? Competitive versus optimal or socially optimal so these are going to differ, right? Because in the decentralized case, the firm solves this problem by choosing Ki. The firm maximizes, let's say, this. Okay. In the social planner requires, okay, there is K here and K here. Okay. And actually, social planner does not do that. So let me be entirely correct in my lecture notes. Social planner does not solve a similar problem. Why? Because social planner, most importantly, would realize that this is endogenous. So social planner or the central planner internalize the externality. What does this mean? Well, results are going to differ. Okay, you're going to find a particular Ki star from here. You're going to find a particular K star. I mean, this Ki star, let's say it is denoted in this way. So this is Ki competitive equilibrium. Okay, will be equal to K competitive equilibrium. And here you will find K K optimal. Okay. In general, because of this difference, competitive equilibrium will be different than optimal equilibrium. All right. So let's try to understand this in the simple version of a model with intertemporal optimization. Okay, now we have an intertemporal utility function. Okay, so suppose that this reflects everybody's welfare in the economy. So we want to maximize this by choosing a path of consumption, right? And now, instead of fixing the saving rate, right? Instead of doing that, we basically create this nice and we assume that delta is 0, right? So we basically find this simple resource constraint, all right, where K0 is positive. Now, this is the decentralized version. Why? Because firm will take A as given. All right. So if the decision maker here is the firm, so what I imagine is this. So I am the firm owner. So I have the capital stock. I consume some part of it as the consumer. Then this becomes my saving, and my saving becomes my new investment. That investment increases my capital stock. So I keep doing that. So I'm looking at the capitalist side of this economy now. But it is decentralized because each capitalist is trying to find the optimal solution by himself or herself. So okay, time is 9:42. So let's meet at 10 a.m. Okay?
Okay.
Because it requires a conversion. So let's meet at 10 a.m. We're gonna continue from where we are.
Okay, thank you.
Okay.